For question 1a, the both samples are concluded to belong to the alkyl group of compounds because we can see that in the range of wave number 3200 to 3600, where the OH group that presents in all alcohols will absorb strongly, a sharp band and a low transmittance can be observed in the IR spectra of sample A and sample B. According to the equation, percentage transmittance equals to exit beam over incident beam times 100. Low transmittance percentage in sample A and sample B means that the light exiting are very low, and it could indicate that high amounts of absorbing species present in a sample. In this case is the OH group. Therefore, we can conclude that both A and B belongs to the alkyl group of compound. For question 1b, we conclude that sample A and B are not the same compound. Even though sample A and B belongs to the alkyl group, as mentioned in question 1a, but they actually have different trend of transmittance percentage at wave number below 3000. As you can see, there's different trends of transmittance in the individual graph of sample A and sample B. So for example, at wave number 1050, sample B has a higher transmittance percentage than A, which can generally indicate that sample B has more CO stretch than sample A, so they are a different compound.
So I'm going to discuss about question 2a, which is determine the percentage of ethanol in wine sample. So we are given the values of concentration of ethanol as well as the relative ethanol peak area. So by using the concentration of ethanol as an x-axis and relative ethanol peak area as y-axis, we can produce a graph with the line of equation equals to y equals to 7870x minus 200, and we are given the relative ethanol peak area for the y as 82400. So by substitute the value into the y, we can get the x value equals to 10.50. Now I'm going to discuss about question 2b. Explain why is it necessary to measure the peak areas produced by a number of standards. So firstly, peak area is proportional to the sum of the analyte, and if we use the peak area to plot the graph, we can actually get the concentration of the ethanol which is fall within the range of the standard peak area, and this will show a more accurate results.
To prepare the dilution for the standard solution using the equipment available, first we will need to prepare stock 2, which is the concentration of 100 mg per 100 ml. So by using the equation M1V1 equals to M2V2, we will fix the volume, the final volume, to get the volume needed from the stock. So we will take 20 ml from the stock 1 into 200 ml volumetric flask and fill up the volumetric flask and become the stock 2. So to prepare our standards 20 mg per 100 ml, we'll take 20 ml from the stock 2 into a 100 ml volumetric flask and fill up the volumetric flask and become our 20 mg per 100 ml. So then, to prepare 10 mg per 100 ml, we will take 10 ml from our stock 2 again and put into our
200 ml volumetric flask to become our 10 mg per 100 ml standard. Then to prepare our 5 mg per 100 ml standard, we will take 10 ml from 10 mg per 100 ml standard into a 200 ml volumetric flask, and that will become our 5 mg per 100 ml standard.
Okay, no, we do not think that the chromatograms for caffeine standards were accurately represented because the peak height of 100 ppm is double of 50 ppm, which is correct, but for 200 ppm, that it is not proportionate to the 50 and 100, as you can see here. Yeah, so that's why we think that it's not accurately represented. Okay, no, we do not think that the detail on the pack of the caffeine content are accurately presented because the pack claims that there is 12 milligrams per 100 ml, but 1 ppm is equals to 1 milligram per liter, so it is actually 120 milligrams per liter after conversion. So according to the chromatogram of the caffeine standard, the sample peak height showed that it is lower than 100 ppm, which actually should be higher than 100 ppm.